In open-source AI video production today, character control is not usually handled by one single system. It is managed through a stack of tools, each responsible for a different layer of control, and the most common open-source environment for assembling that stack is Comfy UI. Comfy UI has become the practical hub because it provides a graph-based interface for building repeatable pipelines, combining models, and inserting custom nodes for face control, motion control, identity preservation, lip sync, in-painting, and video post-processing. In other words, when people speak about character control in current open-source AI video work, they are often really describing a Comfy UI workflow that links several specialized models rather than a unified animation package in the older sense. The first major problem in character control is identity consistency, keeping the same person or character recognizably stable from frame to frame and, more difficult still, from shot to shot. One of the most important open projects in this area is Consys ID, whose stated purpose is to keep human identity consistent in generated video. This matters because many earlier diffusion video workflows could produce movement, but they drifted in facial structure, proportions, hair, or other identity markers as soon as the shot changed or the motion became complex. Consys ID represents the newer direction of open-source work, where identity is treated as its own control signal rather than left to prompting alone. In practice, users often pair identity-preserving systems like this with reference images, and then run the result through broader Comfy UI pipelines for further editing and competition. The second major problem is motion control, meaning how to make a character move in a deliberate and reproducible way. For this, high-end-diff has remained one of the central open-source tools, especially inside Comfy UI. aim-diff is not simply a make-a-video button. It is used as a motion framework that can be guided by prompts, image sequences, control net conditions, and other structural inputs. This is why it still appears in so many community workflows. It allows motion to be layered on top of an existing image generation pipeline, instead of forcing the user into a closed model with fixed controls. However, aim-diff by itself does not solve character control completely. It is most effective when it is combined with pose guidance, reference conditioning, or face-specific correction tools, because otherwise the generated motion can still cause identity drift or changes in appearance. A closely related family of tools handles pose and structural guidance. Here, ControlNet remains foundational. The importance of ControlNet is that it allows diffusion models to be conditioned on additional structure, such as pose maps, edge maps, depth, segmentation, or other external guides. Instead of relying only on text prompts. For human character control, pose is especially important, and that is why open pose-style workflows remain widely used. Open pose itself is an older but still influential keypoint detection system for body, face, hands, and feet. While DW Pose is a newer whole-body pose estimation project that explicitly builds on the ControlNet ecosystem, and is commonly used as a stronger pose extractor in current workflows. In practical terms, these pose tools do not generate the final video by themselves. They act as the skeleton or motion blueprint that downstream video generation models follow. This makes them central to character control because they let users specify where the body, hands, and face should be, rather than hoping the model will infer them correctly from text. For portrait and upper body animation, Live Portrait has become one of the most important open-source tools. Its significance is slightly different from aim-diff's. Live Portrait is designed specifically for video-driven portrait animation and emphasizes efficiency, controllability, and retargeting. The official project describes it as focusing on better generalization, controllability, and efficiency, and it is framed around stitching and retargeting control, rather than around pure diffusion generation. That distinction matters because a large part of character control in real-world use is not creating a brand new person from text, but taking a reference portrait and driving it reliably with a source video or motion pattern. Live portrait is therefore used heavily when the goal is to animate a character's face, head movement, gaze, and expression in a way that is more direct and operationally stable than many text-to-video systems. In community practice, it is also frequently wrapped into comfy UI through custom nodes, which makes it easier to integrate with lip sync, face swapping, or video enhancement stages. Magic Bane occupies a somewhat different position. It is another major open project for human image animation, but its emphasis is on temporal consistency and faithful preservation of the reference image while following a motion sequence. This makes it especially relevant to the broader problem of converting a still character image into a coherent moving video, without the usual frame-to-frame degradation. In many ways, Magic AIM belongs to the line of research and tooling that tries to bridge still image character design and motion-driven video production. Where live portrait is especially strong for portrait-focused retargeting, Magic AIM speaks more directly to full human image animation with an explicit concern for temporal stability. Even when users do not run the official implementation directly, the concepts it represents, namely motion sequences plus strong appearance preservation plus temporal modeling, have shaped the way many current open-source character animation pipelines are built. Speech-driven control is another major branch, because many AI video use cases involve a character speaking rather than merely moving. In this area, MuseTalk is one of the central open-source tools now in use. Its stated purpose is real-time, high-quality audio-driven lip-syncing, and that makes it especially valuable in production settings where users already have a face, voice track, or finished animation and need to synchronize the mouth movements convincingly. VExpress is another important open-source project in this category. Its official description is explicit, that it generates a talking head video under the control of a reference image, an audio track, and a sequence of control keypoint images. That combination is important because it shows how open-source character control is evolving. In practice, these talking head systems are often inserted late in the pipeline, after the character appearance has been established and the broader shot design is in place. Another notable tool is Mofa Video, which is important because it formalizes controllable image animation through several kinds of motion input rather than a single one. The official project emphasizes that it can animate a single image using trajectories, keypoint sequences, and combinations of those controls. This is significant for character control because different production tasks require different motion abstractions. Sometimes a user wants pose landmarks. Sometimes they want motion trajectories. Sometimes they want both. Mofa Video addresses that more directly than older workflows that were tied to only one conditioning format. As a result, it sits at the more control-oriented end of the open-source landscape and is particularly relevant for users who want a stronger relationship between motion instructions and generated movement. What emerges from all of this is that current open-source character control in AI video is modular, reference-driven, and layered. Identity is handled by tools such as Consys ID and by reference image conditioning. Motion is handled by systems such as Wide Diff, Magic Wide, Live Portrait, and Mofa Video, each with a somewhat different philosophy of control. Structural discipline is imposed through ControlNet and pose extractors such as OpenPose or DWPose. Speech is handled by tools such as MuseTalk and VExpress. Comfy UI sits above these components as the environment in which creators actually combine them into usable workflows. This is why the open-source field feels both powerful and fragmented. It offers substantial control, but that control is usually achieved by chaining multiple systems, each solving one piece of the character problem, rather than providing a complete end-to-end digital actor platform. The practical consequence is that open-source character control today is strongest in four specific scenarios. The first is consistent portrait animation from a source image or source video. The second is pose-guided human animation where the user can supply a body blueprint, DUE. The third is talking head synthesis with audio-driven mouth movement. The fourth is reference-based character consistency within short clips or tightly managed workflows. It is still weaker in long-form shot continuity, highly reliable full-body acting across many camera cuts, and production-grade control over every element of performance in the way a traditional 3D animation rig allows. So the present open-source ecosystem is best understood not as a finished replacement for conventional character animation, but as a flexible and rapidly improving set of tools for steering identity, motion, pose, and speech across generated video.